Good morning, I'm John Frisby of YouthTutors.com and I'm going to run through a coordinate geometry question for you this morning. It certainly features in all AS Maths courses and could feature in a high-level GCSE question for a demanding math syllabus, demanding GCSE math syllabus. So let's look at this. We've got the points A, B and C, 2, 3, minus 4, 3 and 1, 5 lie on the circumference of a circle. I've sketched out this in advance, in true Blue Peter style. Find the equations of the perpendicular bisector of the chords A, B and BC. Now this is a sketch, remember, it's not drawn accurately, but it is very helpful. So if we want to find the equation of the perpendicular bisector of AB, let's start with that. We can see that the y coordinates for B and A are both 3, so this is a horizontal line passing through the points. It's the horizontal line y equals 3. It's also, you can see from the x coordinates, it goes from minus 4 to 2, so it's 6 units long. So if we go along from 3 units from here, we would reach x equals minus 1, and that would become the perpendicular bisector of AB. So the perpendicular bisector of AB is x equals minus 1, a vertical line here. And I'm going to put that in here. For the perpendicular bisector for BC, now I'm going to sketch it in very roughly. And it would be helpful to know the midpoint of BC because it's a bisector. So if we look at the x coordinates, goes from minus 4 to plus 1, so that's 5 units long. So if we go along 2.5 units, that would take us to x is minus 1.5. The y difference is from 3 to 5, so that is 2 units long. So this would be 1 unit up from 3, so it would be minus 1.54. I'll put that over here. So the midpoint of BC equals minus 1.54. Now if I want to use y equals mx plus c, the equation of the straight line for the perpendicular bisector, I could do with finding the gradient of this perpendicular bisector here. So if I could find out the gradient of BC, then I could use m1 m2 equals minus 1 to find out the gradient of our bisector line. So let's find out the gradient of BC. Gradient of BC equals delta y over delta x. The change in y from B to C is from 3 to 5, so 5 minus 3. The change in x is...
Wait, can you make that minus a little bit clearer, John?
Yes,
looks like a dot.
Thank you.
No worries.
Cameraman, that's very good. The change in x from B to C is from minus 4 to 1. So that is 1 minus 4, which is gives 2/5. Now that is the gradient of BC. I'm going to call that M1. I want M2, the gradient of the perpendicular bisector, and we know that M1, M2 equals minus 1, so M2 will equal minus 1 over 2/5 equals minus 5 over 2. So we know that this here, m2 equals minus 5 over 2. And now I can use y equals mx plus c. Y equals mx plus c for the perpendicular bisector. I'm going to use the point minus 1.54. So it becomes 4 equals, the gradient was minus 5 over 2. The x-coordinate was minus 1.5. Brackets very important here. Plus c, which we don't know yet. We rearrange that and we'll get c equals 4 minus 3.75. 1.5 times 2.5 is 3.75.
Can you just make that 0.5 on the 1.5 just a little bit clearer? Yeah.
Yeah, great.
That one there.
Thank you. 1.5 times 5 over 2 is 3.75. Minus times a minus is a plus. That becomes plus 3.75. Comes over this side, so it becomes 4 minus 3, 7.5. And I've just rearranged that. And so the intercept on the y-axis, c, equals 0.25. I was about to try and roll up that board then, which you can't do. And so now we can write the equation of the perpendicular to BC will be y equals minus 5 over 2x plus 0.25. Write that a bit more clearly. Okay, yeah. And we could of course write that as y equals 0.25 minus 5 over 2x. I could change this so it becomes 2y equals 0.5 minus 5x, but I'm going to leave it in the y equals form. It's easier to work with. So we've got those two equations. Part B, find the coordinates of the centre of the circle. We're going to use the principle that any perpendicular bisector of a chord will pass through the centre of a circle O. So if we've got two chords and they've both got perpendicular bisectors, where they join, where they cross, will be the centre of the circle. In our diagram, I'll do this in colour, we've got a perpendicular bisector here, and we've got a perpendicular bisector here, and we know they're going to meet round about this area. I'll mark that in there, that point, as 0.25. And so what we're going to use is we would normally put the two perpendicular bisectors equal to each other because they would start with y equals. The difference to this one is that we've got an equation x equals minus 1. We don't have a y equals for that line. So I'm going to start off by writing the y equals minus 5 over 2x plus 0.25. That is our equation of this bisector. The other one is that x equals minus 1. So if we put in x equals minus 1 for this, y equals minus 5 over 2 times minus 1 plus 0.25, we will get y equals 5 over 2 plus 0.25 because they're becoming positive. That's 2.5 equals 2.75. That will be our y coordinate for the centre of the circle, and it will lie on the x equals minus 1 line. So the coordinates of the centre would be minus 1, 2.75. I think that's a fairly tricky question. The main difference to normal being the two lines that are intersecting, the bisectors, one is in the format y equals mx plus c, the other one is just x equals minus 1, and that can throw people out a little bit when they're thinking about this. So you've got the two equations, x equals minus 1 and y equals minus 5 over 2x plus 0.25. You've got the coordinates of the centre of the circle. I would suggest that you try and do this from the blank question sheet yourself, preferably beforehand, but if you've done it beforehand that's great, but certainly you should try and write it out yourself. Don't just watch the video, see if you can write a solution to yourself and use the video as a checking device. Okay, I hope that helps. I'll see you in the next video for YouthTutors.com.